Okay, so today we are going to be kind of reviewing these words. And it was kind of supposed to be like an art project, so we're going to talk through it together and hopefully make it make sense. If you want to flick the light out so you can see this a little better, that'd be good. Okay. Alright, so when we do torn art, I'll kind of explain that really quick because that's what it says this is on the assignment. So torn art, you take random pieces of construction paper and you do exactly what it says. You just tear the construction paper in different ways. So we're going to pull these back, and you always want, and this is a project that you might find interesting later on. I don't know, you're high schoolers, maybe not, but I did this a lot with middle school and with littler people. But you always want your torn art piece to be smaller than your thumbnail. So that's kind of important for what we're doing. All right, once again, we're going to think about the pointillism that we did the other day. We're going to think about what we've already discussed. So when we consider the pointillism that we did the other day, what was important about each of the little dots that we had? Or what did we compare the little dots to? Somebody whispered atoms. Yeah, atoms. Each little dot was an atom. So if we look at this paper, we are going to make like a visual representation of these words. So the first one, atom, that might look like this. We have one dot, a single color, one atom. Okay? So when we think about the word molecule, which is what you just did with the Quizlet, how is a molecule different than an atom? Somebody's got two fingers held up. We might have, if this is one atom, we might have this as a molecule. Why would that be a molecule? Callie? Okay, it's two bonded together. All right. Would this be a molecule? So that's a blue and a red. Yeah, this is a molecule because it's any two. So I could leave that. All right. Or I could come back and I could leave the ones that are the same, because that might be a molecule of oxygen or a molecule of hydrogen, or okay. Alright, but if a molecule can be any two put together, what does a compound have to be? Go ahead. Two the same or two different? Look at that D right there. Remember, D stands for different. So we want to have two different. So here's a good question for you. Is a compound also a molecule? Well, if a molecule is any two put together, and a compound is any two different, two or more different put together, then a compound is a molecule, but a molecule is not necessarily a compound, because we want to differentiate. We want to say that a compound is different atoms. Okay? All right, so if we know that an atom is just one single piece, but an element is made of all the same atoms, like how could we show that? What would you do if you were the one with the paper? That was kind of the point of the whole thing, is if you were the one doing this, how would you do that? Caden, I saw you shrug like you had an idea. What were you thinking? Okay, well, think about pencil lead in your pencil. Is that just one atom of carbon? No, what is it? Lots of atoms of carbon. So if we have lots of atoms of the same thing, okay, then Oops, I'm moving the paper. That's an element. Okay. So what's a mixture? Maybe blue and red. Okay. Huh? It could be a lot, yeah. We could even have like blue and the red, and then a blue and red stuck together. Maybe even a little bit more of the blue, or a little bit more of the red. Or maybe we have a blue, a red, two reds stuck together, like a molecule of oxygen. Okay, so a mixture. Now, are these guys touching? Are they, so they're not bonded together? So I could move them around, pick out the orange stuff? Yeah, I could. That's the idea of a mixture. A mixture can be taken apart. Okay. Alright, so pure substance. If we know an element is all one kind of atom. Yeah. Okay, so a whole bunch of the same color again, that could be. So a pure substance could be an element. Right? It could be the same thing. But what is another way that you could have a pure substance and it not be an element? Think about the water that you buy at the store. It's supposed to be pure, right? But it's a compound that has two different things, which I'll try to make it a little bit more like water, because water has two hydrogens on one thing. Still not got a pure substance. Still right now I got a mixture, so that's not gonna work. But if I make all of these things the same, is that a pure substance? Yeah. They're not quite yet though. We still got a mixture going. So now we have a pure substance. Because even though they're not an element, it's all the same things in that space. Okay? So hopefully visually that kind of helped you. I know it would be way more interesting if you were up and doing that the same yourself, but we're trying.